How about that? Does that sound better? Oh, so I have 9 minutes of muted stream. Hi, welcome to Made Up of Wires. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to sutton.z.dev to learn more. And we're working on BO4, RBO5, which are Doppleganger 10 and 40. We'll get back to those in a bit. So this is a duplicate between RBO5 and BO4, so Doppelganger 10 and Doppelganger 40. Doppelganger 5's version is 97% identical. So not exactly the same, and we'll see what is different. But let's start a new scratch. Different mic. No. That is a bummer. Welcome, Chameleon. Let me check my sound settings again. Yeah, I am using the right mic now. If I need to do a sound check, let me know, and I'll put in some headphones. I usually don't have any feedback for myself, just I watch the meters. Looking at it though, when I talk at a normal voice, I'm usually up in the red, and it seems a little low today. I don't know why. I don't think I'm doing anything different, but thank you for pointing it out. All right, so let's start a new scratch. That one down closer. Get some idea of what this function is. See if we have any callers for it yet. And if we don't, where else this might exist. The other thing that needs to be done at some point is to pull in some of the header information. So we have one caller, and then another that is not decompiled yet. But it looks like this is a no-args function. We'll see. Oof. Okay, so it calls a lot of other functions, and that's actually nice because we should be able to get signatures, possibly for functions that we don't have yet. We have some variables that look like they're in the Doppelganger entity. These may just be globals, and then a bunch of stuff that's in GDOP. They might be part of the player state there as well. I always forget what that range is. And gentity 64 is the same as the Doppelganger macro. So let's go and fix some of the question mark variables and get this compiling. Lots of noise. So let's start with the globals, and then we'll move to the local variables. There's two ways that I go about doing this. The first is looking in the code, seeing how this is being used, and trying to get an idea of what the size is. So if we have a pointer and then we're adding some value, in this case, it's being shifted one way by 16 and shifted back by 15, which is the equivalent of a multiply by 2, while trying to take care of some of the sign bytes. So this might be a 16-bit value. Let's look. Let's look and see. So I'm gonna first look at see if anybody has used this. So source boss VO4, but then try to find where it is in the data segment as well. So it's not used yet. Okay, so these look like 16-bit values. They're all negative if they're signed. I'm going to go with a signed 16 array. And if that has to change, that's fine. 2OC, since we have this open, I'll look here. So this is either a 32-bit array, and we can go back and see how it's being used here. If there's an index that's multiplied by 4, that's a pretty good hint that that's what it is. There's two options when that happens. It's either a struct that turns out to be 32 bits in size, or it's 32-bit integers. I'm going to go with 32-bit integers, and we'll see if that assumption is correct. When we get these done, then we can go back and regenerate M2C's decomp. This is another one that to me this looks like bytes, 4 bytes, as opposed to 32-bit values. So let's look to see how this is being done. What I'd want to see is something that indicates that the stride is 4, which this says, but then it would be really nice. We don't know what instruction this is associated with yet. So either an instruction that says it's loading a byte, or an additional offset. And I don't see either of those things. So I'm going to go with byte, and I'm going to say that this is an array of 4 byte arrays. We'll see if that pans out or not. It could be structs. It could be like 2.16, 0.8s. Could be 0.16s actually, but we'll see. I'm looking at the values, it doesn't look like that. Next one, this is pointers, and what is it pointers to? Nobody knows. We do. Pointers to 16-bit arrays. Let's look at another one. Stay puffed. Oh, you're speaking my language. So I'm going to go with signed 16s. This may be 4 byte values as well. The 0201 looks bitey. 00FF looks bitey. Oh, these are actually, they're inverted. So I'm going to say these are bytes. This is an array of pointers to 4 byte arrays. Oy, that is. Let's see if I can write the. So we have unsigned 8 pointer array of 4 byte values. No, that's going to be an array of. I'm going to have to do some typed Fs here. So type def, we'll call this one 4 byte. It looks like I don't know, something's happening that maybe rid of all these. Not worried about that. I keep getting indented. Okay, there we go. So then we have an array of those. So we have a type def. Okay, and now we have an array of pointers to those. So I think that's fine. Gross, but fine. And then we have one more. This looks like it may be a... What? It's in the header. This may be like an animation lookup or a palette lookup. So it is, I'm going to just say that it's a void star. I know that they're pointers, but I don't know what they are, and I don't know if it may matter. So let's look at header and see if we can get the type. So it's the third entry in this 0034. And let's look at what comes after the layout structure. So that's gonna be in, like, we'll just choose a stage, STN01 header. So sprite banks would be what it is. Let's look at library header. Okay, that one does have sprite banks. So this is the sprite banks, and it's just considered a signed 16 pointer array. All right, so now we have all of the types for the globals. What I'm hoping is possible that I didn't screw anything up. I'm going to take all of these and put them in the context, and then decompile again and see if that improved anything. So we do have a few additional types, maybe. Not really, but maybe some corrected types. Not too much. I will pull that though, and then we can worry about what are the local variables that are missing. Weird that there's explicit references to jump tables. So the switches are totally broken. That sucks. Unable to parse jump table. That's a first. That may be worth looking at M2C. Or it might be worth just ignoring all of that and going to the PSP version and throwing this one out. So it doesn't know the type for this argument. I'm gonna just assume sign32 and we can change it if necessary. I'm guessing that this is going to be an argument to another function as well, so we'll call that sign32. I'm hoping that's enough. It's not. I was hoping that was enough to compile. So we have, I guess, some case statements that are outside of the switch. They're supposed to be part of this switch. I'm going to just move them up there. Yeah, this is kind of gross. I may go to the PSP version earlier than I normally would. %, though, isn't bad. It's better than I expected it to be. Okay. So there's a bunch of really gross operations. I'm actually going to go to the PSP version early, and primarily because there's a lot of jumps, there's a lot of really nested conditions, and I'd rather work those out through the PSP version, which I think will be a little more forgiving. So I need to find some unique values. 6A0 is probably the best bet, and that'll help me find. Is your entropy gravity well, is your Stay Puft Marshmallow also knitted? And this is the only function that uses that sound effect. All right, so we'll start a new one. I usually like doing this later because in some ways, I feel like the PSP is cheating, but we have to match it eventually anyway, so why not start there? So we have to match the types again. PSP only has one unknown type. I'm going to copy these types over. I don't like necessarily using the PSP declarations. What should I do? There's so many globals. So many globals. It's possible that most of those globals fall away. I want the structure of the PSP. Actually, this structure does not look that different, so maybe I'm fretting for nothing. Maybe I should just plow ahead with the PlayStation version. Okay, I'm going to do that. Sorry, PSP. So we'll just start going down from the top and get this saved, and away we go. So we have some stack issues that we'll have to deal with. I will post links to both of these in chat. Appreciate everybody coming by, as always. And I'm going to keep the PSP side by side for me. You won't be able to see side by side. I will, and I'm just going to be referencing this as I go down, trying to keep track of ordering. So PSP is going to be better for what order these statements actually occur in. And then if there's any changes in structure, I'll call those out specifically. So I'm pretty sure that this is the order. There's a 3 local variables that are all set to 0. That's the same in the PSP version as well. I'm going to do a global replace for Doppleganger underscore. All of those will be Doppleganger dot. And then I need to fix these others, 371. I guess I could just do a search and replace for that as well. So there, and now that all those are done, I can get rid of all these from the context. I'm going to move all of, should I move all these back? These first ones, they're all going to be fields in Doppelganger, so I'm going to move these into the source code section so that I can get rid of them. I need to go through and look all these up, and then we can get rid of those one by one. So I'm going to look in the US symbols table, and I'm looking for G entities 64. That's the start of Doppelganger. I added all these symbols for Doppelganger, and I mentioned this before, but it's not ideal. And the reason it's not ideal is because there are other things that use G entity 64, and when people decompile those, they're all going to show up as Doppelganger. And some people might be confused, but that's what I chose to do. I did that because it's used in 2 different overlays, and I didn't want to duplicate the symbols in 2 different overlays, and they're not part of the Doppelganger overlay. These symbols all come earlier, so they're... I guess I could have added a... That's probably what I should have done. Added a separate symbol table altogether, and then included that in the split config. Oh well, that's not what I did. So Doppelganger starts and ends here. Let's see. Does that cover all of it? Yes. So these are all entities in Doppelganger. We just have to figure out what those are. So this is +4. And the way that this is done is by taking the address that's baked into the symbol and subtracting the starting address of that struct. Just simple math, just happens to be in hex, but third grade math. All right, so now we know all of these, and I can go and look at the entity struct, which hopefully has all of these in it. We should look at position Y. Position Y is a struct, a fixed 32. It allows, or sorry, it's a union. One of the fields in the union allows 32-bit access to that size. The other allows 16-bit access to the high side and the low side. And so let's look at that and see what is being loaded there. This is on line 396, and it does look like it is legitimately loading val. So we'll do that. Doppleganger dot pos y dot val, and this is a fixed value, so this ends up just being -1, and we can confirm that. What is it mad about? Oh, this is what it's mad about. I can't just leave naked numbers up here. Wait on 396. All that looks right. Loading the value FFFF, which is -1. And then storing it as a 32-bit value at offset Y. So one down. Do we have any more instances of that? All right, so now going back, what is offset 34? Flags. Run into this one before. And 3C is hitbox state. Offset 49. N frame invincibility. N frames invincibility. So I think the speedrunner guys call those I frames, invincibility frames. That always gets me because I frames are intermediate frames in video encoding protocols. And then last one, offset 56 is animation curve. All right, so we got all those done, and now I'm going to look at GDOP and find which one of these may or may not be within GDOP. GDOP is the player state. Player state usually we call gplayer, but this one's for Doppelganger. Alucard and Doppelganger have effectively identical code. And so they use a lot of the same structures as well. this is the range for a GDOP. So I need to look for 1D for a 20. Anything after that, but before 4D AFO. Sorry, 4DFO. So all of these are part of GDOP. And these are a pain to figure out. Actually, the GDOP variables, we should be able to get rid of those as well. And entity 64, we should be able to get rid of that as well. That one's gone already. G-pads pressed. That's index 1, so that's controller 2. So we're only, the number of globals that haven't had other symbols associated with them, anonymous globals, or not anonymous, but unnamed globals, is actually pretty small now. But we do have to go through and figure this out. So the way I'm going to do that is by calculating the offsets first, and then unfortunately, the way I should really fix this, but I think this is going to be the only case where we have an additional player object. Richter, I'm guessing, has been taken care of already, unless somebody didn't realize player state was part of that as well. We don't have offsets. We have addresses for player state, and that makes these hard to figure out, but it's possible. So fortunately, all of these are, oh, I missed the D. So what do we have? B, C, D. So these are all prefixed with the 3. Fortunately, this math is pretty easy. The offsets are at nice round numbers. B0 minus 20 is going to be 90. C0 is going to be A2. D, C, D, A. And E is going to be C0. Okay. So we know all these. Now we have to go through and figure out what the equivalent address would be for player. So I'm going to go actually we can just open game.h. Everything will be in there. So player state normally starts at this BD0. So basically I'm going to create a table here. And this will have my BD0 equivalent offsets. And I have to go through and add all of these. And that math is less fun. That I can't do in my head. Some of these are close enough that I can do. And it's possible that I screwed all these up and my offsets are wrong, but the types will tell us if that's correct. And later on, I should actually spot check some of these before going too far. Let's double check. So timers, that's timer 0. So timer 0, timer 1, 3, 4A. So basically a bunch of these are going to be timers. All of the first several. F60 is unknown 40. So I think we are in a good spot. So I'll keep doing what I'm doing. Lots of timers. I'm shocked at how many timers. Oops, wrong window. All right, last one. Okay, so I think those are right. Let's look for each of them. 2F72, previous step S. Unknown 6A. Followed by unknown 6C. And finally, unknown 6E. Nope, unknown 70. All right, so we got them all. To move that back over. That's one of the things I think I dislike the most when decompiling is having to map offsets into all these other symbols. So timers starts, I'm going to figure out the timers first. This starts at F00. So the first one is going to be timers 0. We need to divide each of these by 2 to get the index, the last digit. E is 14, so that's 7. 14 is 20, so that's 10. 18 is 24. It's 12. Okay, so we have all of those. And now we can go and start doing the replacements. And I completely expect to have made a mistake in here, but this it will be caught by other tools. So I'm not terribly concerned. And so now we move on. These are no longer timers, just unknown fields. I was considering going through and spending a stream naming things. We have all these unknown variables. It would be nice to go through and name them. There are other ones that I found on the stream already that I've never gone back and named. When I was doing the healing chair, there was stuff in there that we found the meaning of that I never went back and fixed or submitted a change for. Speaking of changes, I did want to see if my CI build is building. And it does look good. All right, that's good. So I will get that cleaned up later and send that out for PR. And finally, we'll have a bunch of this code back and working. So we're left with just about 7 globals that are of any importance, which is nice. Much smaller set than we started with, where there was, what, close to 30 probably. All those are gone now. And so we can start working on what we need to work on. So there's some simple references. Oh, I need to go way to the top. I'm going to be looking for major things first. And kind of on the side, I have this PSP version open as well. I'll just be cross-referencing that to try to figure out what might be going on. So var S0 this looks like it's part of a loop. Or sorry, var S1. Var S1 may be, I was going to say an I variable, but it's being used as an index here. The PSP, is it being incremented by 4? It's not being incremented by 4, so I think that's just a bug in there could be, yeah, I'm not going to say. So I'm going to change this to a I. So I, what? Looks like I less than 16. And then we can put that everywhere we have var S1. We'll use I instead. And get rid of it down here. Plus equals 4 is just a bug with how M2C does things. So we also have this var S0. This, I think, is an optimization. It's related to the timers. I'm going to pull this up. If we look at the PSP version, it's doing this check before the switches, which is related. It's possible that this is the for condition is, let me see. No, the loop continues regardless of what's going on. But so we're taking an index into the timers and checking that against 0. The unknown 330 part of it is odd. But I'm going to go with this being a reference to a particular timer. No, it's not. So this is actually a range check. But we'll figure that out in a little bit. Var S0. And are we incrementing var S0? We were down here. So this is the I version of var S0. So var S0, we're going to take the timer. This is saying var 0 is greater than 0 and less than 32, I think. I think that's what this is trying to say. We have all of these cases that are just breaks. I'm going to get rid of all of them and just leave 2 and 15. I do need to declare I. Back out some of those changes, declare I. And then I'll go back here. So here we're looking at timers again. This looks like is the value of timers 1. And is var 0 which is what was var 0? Less than the value immediately after timers, which is the VRAM flag, which doesn't make sense. I'm not sure. We'll come back. The var 0, in all of these cases, this is related to a timer. So I'm going to replace that with timers I and get rid of these. And then any references to var 0, I'm going to get rid of as well. I need to check block 15. Block 15 is just continuing. This while is also doesn't make sense anymore. So all of these I can get rid of. Those will be increment it as necessary. This go to block 15 does not make a difference anymore either. So I think that's all this is. So I deleted something that I shouldn't have. Okay, 75, not moving backwards. There are some conditions. So I do have those conditions wrong. I will go back through and look at the PSP version eventually. I just want to get this cleaned up as much as possible. So here, this demo timer, we have a decrement. I'm going to treat this as truthy. We'll see. The PSP will tell us. So here we're checking. We're negating. We're seeing if there are changes that have happened. Are there buttons pressed in pad held that are not in pad tapped? Temp 1 is unnecessary, and this can be a and equals. I'm guessing that there is not a separate variable here. Odd that this is being read, but then not being used until way down here. So Varus 4 is Doppleganger step, and I don't really see a reason for pulling that out into a separate variable. And my guess is that it's an optimization that there's been so it's either an optimization or there's some missing code. This is a range, I think, as well. So this is the difference greater than 10? Yeah, so this may be and. Basically, are these the same, or is unknown 6C at least 10 smaller than unknown 6A? This is probably fine the way that it is. So this var S4, I'm just going to get rid of that, and we'll replace all those with Doppelganger stuff. I really don't think that it's a variable. Yeah, I think this is just an optimization. And then likewise, Varus 3. is also not really a variable. It's just being pulled out because it knows that it's going to be used. I'm a little surprised that all these aren't var s3, because that is the doppelganger step, unless there's one reason to do that, and that's that doppelganger step is changing. And we want the old value of it, but my guess is that's not. Or it's the 0, and the 0 is being set for both of them. So this is, yeah, this does need to be preserved. So I was wrong. I got to revert all those. So we'll mark that step and step S then. RS4 is step. And RS3 is step S. The reason I'm a little more confident that those are actually variables that are being set is because they are getting set here as well. And you can't tell, but it does look like these are coming from fields in that doppelganger struct. So I didn't think that was the case, but I'm wrong. So I do want to find where those were being used and get rid of the casts. Let's go up here, make sure that those are the types could be wrong, but I'm going to leave them like that for now. var s02 this looks like some type of, okay, so it's status, so we call that status, and those are going to be there are flags for those. And we can look that up quickly. I'm a little surprised we don't have a enum for 0. But now going back, having all those values, we can look at when status is getting set. What those values are. So 20, for example, is crouch. Oh, but this is, yeah, this is. Here we're getting rid of the unknown 8 status, whatever that is. No. Oh, this is interesting. The timers is being set to V03. That's odd. Oh, am I not allowed to, is there no tilde equals? And equals, yeah, and equals tilde. Not getting better, not getting better. Var v0 is anim set. These are all animation sets that are in the overlay. I would have to go look just to make sure I don't get those wrong. This is going to be just a 1, index 1. The top bit tells us whether or not it's in the overlay or in the main DRA game engine. So we can use the anim set OVL macro to get that, and that gives us the same value. And basically anywhere we see things like that, it's worth replacing them. Same thing with palette. This is PAL OVL. Why these don't come back as negative values, I don't know. This will be -2, or sorry, not -2, just 2. And almost universally, when I see that -07 FFF, I know that's going to be an overlay index. And whenever I see PAL OVL, I think it has something to do with the PAL framework or television standard, but it does not. $40,000 is dead. $4,000 is poison. 100,000 is unknown. $10,000 is possibly freezing. 80 stone. This reminds me of a function in DRA that has a bunch of these macros, but this one is much simpler. varv1 is velocity x. This is taking the absolute value and then comparing that to 20, no, 2. Let's look at, and we should see the abs function being called on the PSP. It'd be good to compare. 346 is where this one would be. And we get all the right instructions. The wrong. The wrong structure, but now that's fixed. Most of the time, shoot, there's an else for things like this. When a variable gets set, and then there's a condition, and then in the condition it's set to something else. Often that's an else. Not always. Very rarely is it a ternary. And this is saying otherwise. Let's revert that and see. Okay, it doesn't change the code generation. The function call, though, is missing. This function call doesn't seem to exist. Possibly hallucinated by M2C. Yeah, I'm not sure. So this the status, loading the status is there, but then it seems to fall into this logic without a branch necessarily. That's weird. When there's two branches going to the same, or two labels going to the same thing, that's usually an indication that something is wrong. None of this is making much progress on any of these. I don't know if I have that macro. Oh, this actually, I'm going to revert a bunch of that. That's actually very bad for matching. Let's look at this block 115. That's not there anymore. Okay, I'm gonna look and see what the PSP version is looking like, if we're close, far, or otherwise. 382, it's really not liking the expansion of this this macro, or not macro, this statement. So let's figure this out. So we're taking the current frame and basically shifting left by 1, so multiplying by 2. And my guess is that that is just because that's the size of this 118. So I'm just going to make this a index into that. And we don't have to cast everything like that anymore. Let's look at what the definition of that is. Sine 16, that's fine. And this is a sine 32, so that's fine as well. Let's conversion from int to short. Oh, this sine 16 array, we're treating it as an array. And what is our 591C? It is a S16 pointer star. So let's dereference that. 65% on the PSP side. Not definitely not the best. All right, so one thing I wanted to do is check this absolute value down on line 346 and see if that looks the same. We should see a JAL to abs, and there we go. Abs is a built-in on GCC and a function call on the Allegrix MetroWorks component. Status 1 is bat. So Doppleganger is in bat form. Step 9, I do actually know what that is. I think. No, we don't. We don't know what that is. The steps are listed here, and we know 1, 2, 3, 4, 5, 6. We know through 6, and then we don't know 7, 8, or 9. All right, so we'll copy this back. I don't think it's going to change much, if anything, on the side. So let's check. I'm going to spend a little time on the PSP side. There was a bunch of these where a bunch of expressions basically had the same additional code. So on 177, this might be an easy thing to figure out. So step S, we've already pulled out step S into it's being pulled out into A0, but it turns out it looks like that there is no argument to these functions. Let's look at player step walk. We don't have anything in the context. Yeah, it is void. So because GCC was putting these into the A0 register, M2C thinks that they're arguments to this function, but they're not. It's just reusing that register, and it knows that the compiler knows that it doesn't need to preserve A0 because that function has a void type, and so it can put whatever it wants there. The status looks like it's also not getting set every condition, and my guess is that it's getting set somewhere else. Let's look at where status is used, what register that's associated with. No, it's not being used there either. So where is status being set? Or not set, but used. I don't see that it's being assigned anywhere. Oh, here. 323. And looks like register S8. No, S1. Yeah, so we're writing the value of S1. So let's go back and look. We should see S1 being set throughout this switch down here, but getting up into the 230s, around line 230, where is, so 232, oh, I did that wrong. I need to, not what register is the one we're using, but what register is the one that that the PSP is using. That's what I need. So this was 3. It is S1 over here too. So we should see relatively consistent use of that on both sides. And then 237, which I'm guessing is the top of this. So here we're setting status to 0. And we should get that instruction there. And all of these other cases, this is just an optimization. And we don't need this default case then. Basically, the compiler is just saying, I'm going to end up setting status to 0 regardless of what branch I take. Thank you, Dig Down Deep. Regardless of which of these breaks I end up hitting and jumping down, status is going to get set to 0. So I'm just going to put that in the branch delay slot and effectively get that for free. But it's not, wasn't part of the original code. And all of these are going to be the same thing, probably, where the argument to that function is not actually there. It's just that step S is in the A0 register. So pretty quickly we should be able to get relatively or closer by getting rid of a bunch of this argument setting. 183. We have a move here. I don't know what's causing that. Our jump table is totally broken. Not worried about that at the moment. That may be related to a bunch of cases that I got rid of in the upper jump tables. Alright, so that all looks much better. We have some registers and offsets into stack pointers. I think that's all fine as well. RS5 down here, that looks fine as well. And then there's a bunch of code down here that we'll figure out in a little. So I think what is happening Oh, you playing tonight? Is there a... Hey Nate, good to have you back. Oh. I wish I was good enough to race, but alas, I'm not. I should stop by Long Library and watch. I did the other day. I watched Mott's and some others. And everybody just knows the castle so much better than anything that I would ever do. I'm going to try rearranging these into like what the like a chronological order, basically. I'm not sure what might be going on here. Oh, my condition is totally wrong. The switch Switch is actually okay. I'm gonna... Fascist. Fascist. Fascists do like beating things, don't they? I kid. Do you have a video uploaded of that? You're able to get a 10-minute arbitrary code execution. Is that with manual input or a TAS? I'm going to take this back over to the PlayStation. Tightened up the PlayStation nicely, which is usually the case. I really do want to, let's try this one more time. So this switch shouldn't need any of the cases that are just breaks. Let's go here. And so I do want to see what happens when I get rid of those. I could use the keyboard correctly. Should probably learn how to do that one day. So that doesn't affect anything. These are all breaks. I don't expect this to produce any different code. It does though. So when you have a switch that's this simple, it's easily convertible into if-else-if conditions. It's just really surprising. I guess that's the difference between having the optimizer and not. There's no difference between this and the other. Okay, so down on 77. Checking out the appropriateness of oh, this is your one from before. I'm pretty sure I've seen this. Oh, you did that on a real hardware. I still want to go through that video and find exactly how, like, where the errors are in code that allow that to happen. I think that would be interesting. So this switch down here, this is gonna kind of be the same thing where we need those extra cases even though they don't do anything. Brecca. And we need them just so that the jump table gets generated. I want to look at this timer and check if this is actually a zero comparison or not. It looks, oh no, here, it looks like it is. If we didn't do the zero comparison, oh, this is a 32-bit value, it doesn't matter. If it's 16-bit value, you'd get possibly some sign extension related stuff. We're missing a mask here, so let's add it. Missing a mask on 119 as well. I have this wrong. Oh, these are buttons, and I need to switch them with the button macros. I can't. It won't matter for the way that I have the context set up unless I put the right buttons in the PSP and the PlayStation context. So what I'm going to do instead to get this ready is these are going to be the same as these two buttons. I can put the buttons, so 80 and 20. I can go find the buttons. Pad get moved. Where is? Where are the pads? Game. Oh, so 80 is square. And 20 is circle. So these are attack buttons. Basically negating the attack. These are different for PSP. Let me do that just to see if that's working. Add circle. It's frustrating that those buttons are different, but that's what it is. No use crying over it. All right, so now we can go back over here and those instructions are correct. Now we have the right immediate values. I'm gonna save this. I think that's all for today. We will get back to this tomorrow. Mostly just a lot of rearranging of things, and none of the code is terribly complicated. Sorry, Nate the Great. We'll be back though. Hope everybody's enjoying it. Good luck on the race tonight. Appreciate it, and when I have some time, I like I said, I would like to go through your arbitrary code execution. I say that a lot, but life gets in the way. Go to soten.z.dev to learn more. We've been working on Doppleganger 10 and 40. Be back tomorrow. That's all I got. Adios.